All right. 4:59. Okay. So I'll just have a minute or two to ask anybody out there. Well, it's not much people out there in Zoom either way. I was just checking out attendance, just some housekeeping attendance. So we have some average. I'll work out the proper distribution. So we have a few who have done full attendance or close to full attendance, as in face-to-face, in person. Well, a lot of people are actually online, and there are less who are actually online as well, given the class size of what over 40 students. So I'm getting about 50% attendance, both in hybrid, face-to-face, so in person and online. So I'll just let you know, and more for me to cover myself, to let you know that please attend the classes, ask your questions, and so forth. And like I said before, even in all my courses, take the 2-hour time that you have now to learn about the content of the course. If you're saying you're staying home, try to take the 2 hours and do it. If you're in class, take your notes and ask your questions, right? Because recording or not, a lot of you do not have time to actually play back the recording or play at 1.5 times the speed, because it still takes time to play, right? Even if I have closed captions and all those things. So that's why it's best to be in class and take your notes accordingly. And you just go back home and you go through your content. Again, that's the point of it. Take your 6 hours for the week, for each course. That's what it is. Read over, which most of you won't do, but that's fine. At least I'll tell you again. Read over, prep. Same thing with the assignment. Anybody ready assignment? Right, so for those who have done one, it would have been similar in terms of the format of it, but the whole. So you good with the IPv6, so you good. You can't remember much. Just go back to what you did in the last assignment. Because you could do the IPv6 part, but guess what? You have the IPv4 part to do. And then you have the VLAN part to do. And then you have the tests to show that you're communicating between the different devices. But remember, it's all on the same broadcast domain, but I'm not asking you to connect from one broadcast to another. There's no routing set up in that lab. Right? Now, there's a little caveat, which you all haven't seen it yet, and you wouldn't have done it. There's something called the ETA switch. It's basically the, well, I actually could open it up now and show you, give a little tip on hints. It has being recorded, so you guys should have a look at it properly too. Let me see. Yeah. Let's plug it in here. Main focus really is. Oh no network there. I swear I put. We went to the other page. That sucks. Right. So these symbols. So you'd have seen some of them with a regular switch. Down here and here, a regular. That's okay. You'll just go through it and actually set up the VLAN, right? That is more point and click. There's no CLI for these two guys. You'll figure it out when you use the GNS tree. These guys here, these three ETA switches here, are the ones that you're going to set up the trunks and the VLANs via CLI. Now there's a little change. I'm going to put it up on the forum. I didn't state it in the assignment itself, so that, but something that you can learn on along the way. These switches set up trunk. You have to do some encapsulation .1q. Because these are layer 3 switches, they're not like regular switches. They can actually do routing in this, but we're not focusing on the routing. We're focusing on just the VLAN, which is cool. These it's the same model as well, you're not seeing it here. It's the same model as at the 30. What is going? I think it's a 3475 or so. I can't remember the exact model. Actually, hold on. I have the iOS file here. I'll open that up. Right, it's a 3745. So I could show that this text file was on the Myelin as well. I'll put this up so you guys can go and look for it and download. Just Google search for this. So it's the same 3745 switch, but I tell it to make it an ETA switch. So it functions. It's a router, it's a router, but I told it to become an ETA switch, and now it becomes like a switch. When I go into the GNS tree, I might as well open up the GNS tree, why not? I do have the project open here. Yes, I can open the project now. Yeah, just a quick 3 minutes song. Yeah, I could guys, good afternoon. Oh, I'm muted. Alright, so you guys could check the stream on just check this over for me to be unmuted, right? So you'll get this. I just put it up on the chat. So yes, sorry guys, I was muted in Zoom. I didn't do much, don't worry. Right. Assignment 1. Right, so I also have online, I also had, so this is the assignment itself in GNS3. Right, of course I have to zoom in. Right, so this is the actual GNS3. If I mouse over this guy, you're going to get a whole lot of interfaces are set up here. That's, I just decided to put all of them. So I load up this with 2 sets of switching interfaces, the focus ones, and you'll see they're connected right now. And that's what it is in the GNS3. So when you guys open it up, you'll see this. There is fast Ethernet 1, 0, 1, 1, etc. Those are the primary ones. So fast Ethernet 1, whatever it is, that's the cabling that you're going to be using. They're already connected, so you guys have no problems with that. If you break it, well, then you just re-download or you reconfigure, right? In your design, you're going to plan out and say, okay, each device, this interface, this is the switch, what interfaces are set up. What I did not give you, I should have done that, was a local connection details file where you're mapping out each switch and you're going to map out all the VLANs and ports that are, for each port, you're going to put what VLAN it's mapping to, or trunk, and what device is on that. Now there's the the black hole VLAN. There's nothing connected to that, so you just say black hole VLAN, but I did not give that file out, but it's not a requirement for the assignment. I will still post it on any assignment block listing so that you could use that as to help you out document your switching information. We use that method. Let me open the file actually. Do I have it here? Yeah, I think I have it. I have that. Yeah, it's under labs. Right. So I told you about it before, but I will show you it now. Don't be too scared of this stuff too much. Let me just fix this up. Right. Right, so let me just go back to the GNS a little bit. Right, so again, like I said, each switch here is, right now it's not documented in any form or fashion. So the only way that you have knowledge about this stuff is inside the GNS3 diagram. There's no document, no text file, no Word document, and so forth. So you will have to start to do your documentation, and that's part of the assignment. In addition to that, the PCs too, you will have to do a table. The assignment document does have the table, so you could fill that out. But the thing about it, the switch does not have that, and it's going to be difficult for you to do your configurations and stuff because the only way you know it is from there. So you have to put some place to put it or record it. So what I'm going to do is assistance. It's not mandatory to use this. So I gave you this file. I'm going to upload this file later on, where it's basically, don't worry. So this is actually pulled off from an actual upgrade that we have done some years ago, 2012. I just change the dates and stuff to know that it's not that, and clean out some other identifying information. So nothing here will identify this came from any specific campus or building or so forth. Everything here is now generic. I even put in blue building and stuff, so you guys will see how to name your building, blue or Natsai or so forth. There's a building number which you can use. You create your building numbers based on your design. There's a level. So this level is 1, which is ground floor, level 1, level 2, level 3. That's what you call it. Or you could call it first floor, second. Location or room. So this is where the switch. So this is for every single switch in this sheet. Every single switch. So this case is SW1, but you can label it SW11, 12, and so, I don't know, whatever it is. And put where it's located. Now you could make up all these things. All these things. Now, when you actually go on equipment in GNS3, you can actually put the real Catalyst series switch, what it is being used by a show version command. right? There's also IPv4 address. We have not done this yet. Later on in the course, we'll put in management IP addresses. There was a management network, which I have done in the Packet Tracer Labs. You will see I'll block a text with management, and you see 192.168.3 dot something, I think it was. So I think that was the management network. So that is the IP address to fit this. There's also an IPv6 address that is assigned, in this case, to the switch and a MAC address. Now, I just created this IPv6 address. It's different from what we have in our campus, so it's different. Normally it's a naming convention, like a running number. We use the billing number here, like billing number 1. We put the 1 here, and then colon 1 is the running number in that billing, or for that matter, that flow. Right, MAC address. Now, this switch now has every single port on that switch is down documented to have a VLAN ID and the patch panel drop number. So this is where it maps out to the switch's configuration to what it is in the real world. So this part of it is what is in the real world. For your case, in your design, you basically put the port number, and you can actually put out a code. You could call it FA0, 0, something like that. And you work from it. And then when you reach the end, remember we reach up to 15, is that, then you come down here and you can put FA0, FA, I think it's 2/0, right? So the first one is FA1. Well, actually there's an FA0, so I'm going to skip ahead. I'm going to put FA1, come on, right? 1.0, going all the way down to there. And then this is going to start over to 1, and 2, and 3, right? Come on, I'm just tabbing out back to the GNS tree, just to look back and see. Right? So yes, you see that FR setting at 2/0 is empty and stuff, right? So that's the rest of it. So this has a lot of stuff, connections on it, but that's fine. Once you reach down to the end here, you could always add more rows. This was meant to deal with like a it's supposed to be 48 port switch. That should go all the way down to 52. But you could add more going on the line. But this is going to help you because it's going to tell you this interface. For that matter, you can actually put it one time, right? FA1/, right? Right. And you could go down the line. So you can know which port has which VLAN, patch panel, or PC for that matter. So you can tell it which PC is connected and then document, okay, which port number the PC is, right? So I'm gonna upload this to help you for the assignment. You don't have to fill this in. That's up to you. But I'm using this to help you. Why? Because this sheet can be used for those who are going out there into the networking environment, planning out for your network design. I would recommend you fill out every single switch that you have on your network and work or wherever it is you're working in. Even if it's a regular buy out the shelf switch, fill this out here. If it's an off the shelf switch, chances are the VLAN ID will be like 1, or just put 1 as the default, and they go with that. And they will have somebody connected. If there's nothing, you can always put not connected. I think somewhere here, look, free, nobody's connected. Look at that, VLAN 999. This is the black hole VLAN I created. You don't have to create that. Trunk uplink, downlink, etc. 3 ports, right? So you have descriptions of what it is. That is what this is about. So I'll leave you guys to check this out and use it as a guidance to help you build out your switches. And that could be the first thing you do when you get the assignment, when you start working on the assignment. Right. So that's this. That's a GNS tree. Let me move it out. Right. I also posted the same assignment as videos on how to install a GNS tree. I use that version 2.24 or something like that. It's an old one, but I use that because it works. It does the job. Nothing too fancy required here. And then I showed you how to. I think it was another procedure, but I'm not sure what it is. I can't remember what it was. I don't know if it's related. Right. All right. So that's around on the assignment. Oh yes, I expect you guys to fill out the IPv6 details here. All these IPv4 and v6 are stressed as part of your labeling. All these X's and .X's and double colon X's, that's part of your labeling as well. Right? Yes, feel free to collaborate. Why? Because everything here is going to be unique to your student ID number. More work for the marker, but at the end of the day, you're going to demonstrate via pinging. So you're filling these tables out, but you're going to demonstrate via this and screenshots. This part here, all this is evidence to show that your devices are connecting and communicating with one another. Alright, and you're showing the screenshots here. So it's 5, 10, 15, 20 marks here. And you have the allocations. 20 marks for the actual VLAN configurations. And you notice labels are small amounts. Labels, small amounts. 15 to plan, configure IPv6 on this PC. Same thing with V4. And then you actually build out your network tables below with V6. I think, right, and V4 is up here now. Right, so this is the example how you're going to convert your student ID into these IPv4 values. And I'm using just 2 digits, so if you have zeros, it'll work. Right, so if your ID number is 16. So I went further down to the end of your ID number. Instead of using 16, a lot of people have 160 something something, and we end up having issues, so I went further down to the end. You mean if these two are the same? No. No, that's not a problem. That's different networks. Wouldn't be a problem. The only problem I would have is that these 4 digits are the same for some or at least 2 students. That's the only problem. Because at that point they could copy and so forth and share each other, right? That's the only problem. But other than that, everything else, yeah. So because this could be 79, this could be 80, this could go up to 99, but it will never be 100 because that's just 2 digits, right? It can be 0, and that's okay. And that's why I use 2 sets of octets here. So if this 56 is a different value, 1, 2, 0. All that is valid. 192.0.0, and you go down from that 0. So this can actually be right. So 1 digit more. Worst case, somebody's already 99 here, and they're already 99 as a ID number. Then they just roll up to the next one, which will be 0. So it'll be .0. 816023. Right, so this 34 here. Yeah, we don't want to worry about the last 4.
So what's saying is because that the results are not true, which is a 3, 4, 4. But if it's 7 and 8, which should be true, or 7 and 9, it will also be true for them.
No. So this will be 34. This 34, right? And this value here will be 35, increment 1. Yeah. Remember, you'll notice that the blue is here and not counting the last digit. Oh no, yeah, sorry, that's coincidence. Sorry, it's not just coincidence. So it's actually, that 78 is here, and then that 78 going to 79. So if it's 34, it'll be 35. So that way it will end up becoming a different network altogether. You'll notice I subnetted this to /25s. So half instead of that. So that's more for subnetting. I'm not going to give you VLSM until when we do the OSPF stuff. Yeah, you're going to have fun with OSPF and VLSM. That's why it was the purpose, but once you get the hang of how to do that, it'll help you when you're doing big subnet plans and all these things. Because you'll know how to break it down to smaller pieces. Right, and then the V6, well, do the V6. I think we fixed that problem last semester. So the /80 is what we're looking at. So the /80 gives you this whole block to be a network. So once I start to vary this block, 11, 12 to 21, 22, and so forth, for the networks, so 11, 12, 21, 22, right? That's where it'll end up being unique, because everything else after could be the same, and they'll be on a different, they're not their own network. All right, so that covers that, and everything else is standard. All right, so let me see how fast I could finish this piece, and I'll jump into, I'll just see if I could jump straight into these pieces spanning tree if I can, and we'll go from there. All right, usual, any questions, email or forum, and I'll answer it in the forum. Right, so what we're looking at, fault isolation document. Oh yes, I cannot, because of these screen res and how the projector is, I can't fix this. I got the perfect 1080p. Right now it's 1080p on the projector, but it's chopped. The projector cannot show that, so it's chopping it out. If I change that, it's going to mess up the stuff. The good thing is the Zoom is recording it pretty good. And right now I'm streaming out to YouTube, so those who are on Zoom can get the link on YouTube and then we'll see what this full looks like right now. You'll get a delay of maybe 20 seconds to a minute on what I do, so you could always look at that. All right. All right, so this is more troubleshooting. I would like to go through this so you guys will get an idea of what it is. Can I zoom out of this? Let me try something. I don't like to, but let me see. No. No, there's no way I can zoom out. I can zoom in, but I cannot zoom out. Nah, sorry, I can't zoom out, so you'll have to work with that. Oh, no, did I just hide presenter view? Did I hide my presenter view? No. That's not an issue. All right, now I end up losing my presenter view. That's not good. All right, good. Okay, good. Sorry. Right, which answers describe good practice applying troubleshooting methodologies? Choose two answers. So the first one is perform problem isolation as fast as possible, including not slowing down to document. Sorry. Not slowing down to document your findings. Last step in a good troubleshooting process should be taking action to resolve the root cause of the problem. All right, the last step in a good troubleshooting process should include monitoring the state to ensure that the problem is indeed solved, does not recur. Each worker should know and use the escalation process when they cannot resolve a particular problem. So say choose two answers, or I'll go straight on to here. These are the two last ones you'll want to use. There was a nice, I can't believe this. This place has a lot of things. We had an issue with a switch failed. That was weekend. And they identified it could be the UPS caused that problem, but it wasn't UPS, the switch failed regardless. The problem, so they had to change out the switch, that's okay. The problem was that, I kind of asked them what was the, it was a 700 VA UPS with 4 switches. So a switch usually we use between 100 to 150 watts of power. So a 750 VA UPS is not really 700, it's actually less, it's about 500 to 600 watts. That's volt amps, that's VA. I don't know why, there's a power efficiency thing. So 4 switches on that UPS is going to be using almost 500 So almost more, about 500, 4 to 500 watts, at least that. So imagine you have 500 watts out of 600 on that UPS. So technically, you're not supposed to have so much on a UPS. That's going to give you about 2 minutes run time, because you don't know how old the UPS was, the battery is going to be issue. So that was already overloaded in UPS. So if a switch to fail, it could happen, could have been an overloaded UPS, could have caused that issue too. And the UPS couldn't handle it, or something wrong with the voltage. But the switch failed, I had to change it out. I did ask them what was the load of the UPS at that point, but they said they was too busy trying to resolve the problem as fast as possible. That's what they were doing. And they weren't able to properly document how much power load was on that UPS too. So you came out the environment, you're done, things are working nice and fine, but you didn't solve other problems that was there too. So you have to understand the environment. So that literally happened from weekends. So it happens. And just literally giving you that's happening. So it's not to say that it didn't happen before, maybe. But anyhow, so it should include monitoring to ensure that's the last step they said. It is indeed solved and does not recur, so you always monitor. So in this situation, they change out the switch. So they reconfigure, change it out, and then they're going to monitor to see. But normally, we're normally sorted out. Things will last like months without issues until either that happen again or the switch fails again. That's the only problem we'll end having. So the switches we have in our environment is pretty, once we configure, it's pretty stable. And we don't have to worry until they fail because of hardware failure. It's pretty old, or the environment is too hot and the components overheat and fails, right? So all of this contributed. Not only that, each worker, no one used the escalation process. So this kind of did happen. So we did use the escalation process because the person on site did their diagnosis. They identify, okay, the problem may not be the UPS, problem is the switch. They did their checks and then they escalate, and that's what they did. So they kind of did that one, and then we kind of did that too. So at the end of the day, we did follow this part we're monitoring right now. And just let them know that, they let the users know that it's up and running, but we're monitoring. More or less at the end of the week, should be end of this week, we'll let them know that it's stable. And we normally close the request, close the case, and say, okay, that's done. Right, so this is troubleshooting. The first important perspective is that you can troubleshoot in any process or method that you want, using any process or method. So you build your own methodology, but Cisco has their own steps. Right, all good methods have the same characteristics that result in a faster resolution or better chance of avoiding the same problem in the future. Things like documentation. Right, so you have something called problem isolation and documentation. Right, refers to the process of taking what you know about a possible issue, confirming that there is a problem, and determining which devices, cables could be part of the problem and which ones are not part of the problem. I think you know that, you naturally will do that sometimes. It's also work best when the person troubleshoot document what they find typically in a problem tracking system. So anybody have used, when you raise a case with, let's say, Flow or one of these companies, they have a tracking system that they will record your case. And normally that case number, they will assign either email or something like that. The thing about it is that they have all the technical stuff they keep record of. You don't, you're a user, you don't know about that. But they will keep a track of the customer number, the equipment they use, the model serial number, all those things they will have information of. A good system. And normally when they hand over to someone else, let's say a case, not the case, they're supposed to send a technician, you call back the next day, you call the case number in, they'll open it up, and then they'll assign a technician. Sometimes the case number will have it. So what they do, they document. They're supposed to document what they find. So they will take your initial reports, and then they will ask you, hey, did you try this? And they will run you through some steps too. So all of this is part of troubleshooting. So you're getting it as the user point of view. This is showing you how you're going to deal with it on the other side. Either you're going to be the person dealing with it, the engine dealing with it, or my son, a field technician as well. All of that will be the part of the problem. So the person who's dealing with it, they have to go through those steps. Unfortunately, sometimes when we, like us IT, raise a case, we tell them that we're pretty experienced IT, and this is what we're giving you as our diagnosis. Sometimes they have their script they follow, and they tell you back the same things that you would have tried. Right? Did you unplug it? Did you this? Did you unplug the cable? Is the lights flashing? Is the lights solid? What color? So forth. You'd have given all that information before, but they have to run through their steps, because they're not going to glean from what you report and transfer it into their database. They have to go back through the steps. So it's a problem. Right? So problem isolation should eventually uncover the root cause of the problem. Right? the cause which if fixed will resolve the problem. Size 1 means finding the root cause and fixing if you can't find the root cause or fix that root cause once found, you will escalate. So they normally escalate. So in your case with your modem at home, they will tell you power cycle, plug back in, it normally gets an update and you're good. You get internet access, you're happy. So that's basically, that solved the problem and you're done. They don't escalate. Now if it does not work, like in my case, the fiber was disconnected. And I had no issues because I had a Digicel, so I was load balancing to the other network and I didn't bother. I was just sending my emails and so forth. And they had to escalate because they realized they could not communicate with my equipment. So they said, well, they'll send a field technician. So then they escalate to these field technicians, send them across. And then he come and tell me, hey, your cable got broken. Could be a truck pass or something, I don't know. And I did tell the rep that I said the reason why I'm not complaining too much is because I am using Digicel as my backup link. So I hope they do understand that they are not the only provider there. I'm actually using two. Right? Yeah, because they said they're going to rebate me about 50% or whatever, how much, because I had no internet from them for a month. Almost a month. They said they're going to just rebate me on the remainder. That didn't do that. And I normally pay in advance. So I money lost. But it didn't matter. What am I going to do? Complain and disconnect? Yes, I can. And then take Starlink, right? And don't worry about them again. So most have a defined process, technical support management, and there are cases where these people behave bad, or sometimes you could ask to escalate it to management and their supervisor and so forth as you go along. Normally it's difficult to get to management or managers to deal with the escalation. Right? So of course verify and monitor. Right? Now you need to verify, so you already resolve it. You need to try verify it really work. Few show commands. For our case and equipment, we do show commands to show that the cabling is up or something like that. When we did that in the lab 4.1, remember I did, even though I configured, I went and do a show command to know what I did was configured correctly. The interesting thing about it was there were some commands I did. When I did the show, I said something did not look right because the intended effect was to be in this VLAN. And it didn't look correct. Because only when I go back to the procedure, I realized I missed a step or I was on the wrong switch at that point. So I was looking at the procedure of the second switch, like 22, I think, when I was supposed to be configuring 21. 22 had another VLAN, 21 did not. And that is why you have to have your documentation. So I went back to my table early on and checked it over. So that is where you do your show commands to see, hey, you do a few shows to see everything's working. And you do show commands on your interfaces, see the bandwidth and things like that. All right, and then keep an eye on a period of time. All right, so a deeper look at the problem isolation. So this example, network at a ping problem. Now this is the thing, ping command is very powerful, and that gives you to deal with layer 3. Layer 3 issues. The good thing about layer 3 is that once you sort out layer 3, you can either go up the stack to layer 4, 5, or layer 3 or 4 and 7 or 5, 3, 4, 5, that's what it is, or you go down the stack, layer 2, layer 1. Right, so if layer 3 works, then there's a chance that all the layers below are working, so the layer above is the way you're looking at. Right, and layer 4 will be TCP and TCP or UDP, and that could deal with ports, that could be firewall blocking, ACLs blocking, all as layer 4. And a layer 5 would be application. It could mean that your service is not running. HTTP, FTP, all that is the layers above. Right? So that's how you do your diagnosis. And then the offer is going below. So in terms of a network admin, so it's layer 3 and up. In most cases, a network admin or engineer is involved. Right? And if it's layer 3 or below layer 3, most likely it's like a field technician or PC tech or something like that is involved. Right? Because these things are dealing with, it depends. If it's VLAN involved, then it might be engineers. So if it's a VLAN, then it might actually be engineers. That's layer 2, right? VLAN's a layer 2. So if it's a VLAN issue, then it will actually be engineer have to get involved, and that will be escalation. Right? So this is in the case, in this example here, PC 1 and 2 suppose it's on the same VLAN 10. So this is your part of your diagnostic steps when you guys are doing the assignment, and that's what I want to cover. Right? The ping command on PC1 work. Now it does not. Right? So we're looking at some stuff here. we have, so first things first is that, hey, are you in the same broadcast domain? 10.1.1.1 versus 10.1.1.2. I mean, if you look at the mask and all that, you could say, hey, they're supposed to be communicated with one another. In fact, that is when I was testing the assignment to make sure that my trunking was working. That's what I did. I set a PC with the one IP like this, a next PC on the other side, and I actually did a ping on to confirm, and it wasn't pinging. So I want to know, well, is my trunk working between that? And that's literally on the assignment. And what happened was that it did work eventually because it had to end up doing MAC address learning and stuff. So all that had to happen first. So what you should do is set up another device that's on the same switch, same VLAN, and then test one another. That's always your baseline to make sure that's working. And as you spread out to our next device, like in this case here, next switch, then you could do the next test. So ideally, what you should have is another PC, which is at 10.1.1.3 or something like that. And you're supposed to be able to ping one another here easily. Same VLAN, VLAN 10. So keep that in mind. Keep have that PC running. And as you add more and you keep going down, you keep pinging and then you see where the stuff is configured or not. All right, so a few things. One, if you doubt the figure is even correct, so let's look at this. Your diagram, the GNS tree, the packet tracer diagram, if you think that whatever is labeled there is incorrect, the best way is to use the show command and look at what the network device is showing you, telling you, hey, the diagram is showing this is interface faster than at 0, 1 or 1, 1 or 1/11. But when I do a show interfaces, status or summary and all those things, and I did that, I am not getting those, I'm not seeing that. It's doing something else. It's showing the wrong interface connected. Right? So that is why you do that. So if the network topology is confirmed or reconfigured, or you now learn what it's supposed to be, right, you could predict its normal working behavior based on the knowledge of LAN switching and VLANs. That's what it is. It's supposed to say send the packets across. Remember, we're not doing any advanced VLAN tagging, simple VLANs, right? You could predict the frame sent by PC1 to PC2 should flow, right? Because there's simple layer 1 and layer 2 stuff and an IP. That's easy, right? Then you could look at the switch MAC tables to confirm, right, the interfaces which your frame should be forwarded, and you can do show MAC address table and see what it is, right? You could see that find out that the interface connected could be failed. In this case, a layer 1 or layer 2 problem because the interface went down, which can involve interface and VLAN issues. So once it's VLAN again, could be layer 2 in that way. All right, so now that's basically, let me go back. So this is all we have to, this is more or less layer 3 and down below. That's what this one is. In this example here, we're looking at, this is more layer 3 problem isolation. In terms of layer 3, kind of more into the layer 3. Why? Because the amount of different routers we have here. Now, I'm not going to go too much on this. Actually, I'll go into this and then we'll go more detail later on when we start to do routing and stuff. But I'll just covering this so that you'll have an idea on how to troubleshoot layer 3 and up. Right, so in this case, example.com, the .com on PC1's web browser. So that's here. And we're actually pinging, well, what it is, the connect to the web server by using a web browser. So once you start to hear when you start to see names, and you're supposed to know that, once you start to see names and applications like web browser, you'll know what protocols and stuff involved, right? So what two protocols are involved in this situation right now? Higher layer protocols. Right, application, but what is the actual protocol being used? HTTP, right? So you get it there as one. HTTP is one. There's another one here. Right, DNS is the next one, right? So DNS is because it has to resolve the name to an IP address. So if there's a DNS issue, well, how can I get the IP if I can't resolve the name, right? Or communicate the DNS server. So that's what's going to happen. So you have two protocols, and that is where this whole idea of network troubleshooting comes in, right? You can't just say, hey, I can't get to the browser. So what we would do as IT and admins, we would ping www.example.com. We will ping that. Now, two things going to happen. Well, out of two things could happen. One, you get a response of an IP address you're pinging and it works, or you don't. If you get a response, there's a lot of things that give you. One, it's saying that DNS is resolving the IP. Two, it's saying that ICMP port is open to allow ping going through. Three, it's allowing, that means routing is happening out to the internet to get there. So ping in and google.com, and that's the fastest way to test something. Ping google.com. It's going to tell you a lot of protocols that work in the background to allow that to happen. When that does not work, that's where the problem starts. We don't know where. It is like daisy chaining a power strip with power along the way. You know, you're pulling it and then they say you plug in a fan and nothing happens. Well, where's the problem? Is it that strip, that? We don't know. Then you have to go and check every single thing along the way. Right? So it's something like that. Power strips is like layer 1. Right? So your being first act will have happen. We'll try to confirm that it can resolve the host name to the correct by the server. And you then have to determine which of the 6 routers has failed. So they could actually go through some steps. Step 1, right? Yeah, so sorry for those here. You're going to have problems seeing this. Right? I'll just skim through this thing. It's first it sends a default gateway. Then it goes through the routing table of each one and then it goes along the way. And the funny thing about it is that Packet Tracer does a very good job of simulating all these steps along the way because it'll show you as it goes from one device to another device. Right? But the problem is, and it's the same thing with switches too. When we did the Packet Tracer Lab 4.1 examples, we saw the packet, the frame or packet going from one switch to the other switch to the other switch, and it's working. The other case where it didn't go to a switch, but because the lab was set up properly, everything kind of worked out. So it actually went from one to the other. Packet Tracer easily. In GNS3 in the real world, you cannot see where the packet is going. You could only get a result of when you're doing the ping. So this is where you're pinging your destination IP address of the web server. And you're getting a timeout. Now you have to figure out, where is this happening? Which router in this whole list, which one has failed? Is it a switch failure? Is it a router failure? Is it a PC issue? We don't know. So now we have to start to diagnose the next step. So what we would normally do, step 1. So what we're doing here is showing that step 1, we want to see that we're able to communicate with the interface of our router 1. So this is what, when we do routing later on, we will see that. We will actually try to ping the gateway. So the interface here is the gateway. Right? The reason why it has to be the default gateway, because everything else is a switch in between. Even if it's all in a VLAN, and that has to be a default gateway. There's no other device in this between PC 1 and this router 1 that can take out that packet outside that network. Right? There's no other device unless you put a PC that has 2 NICs and you set up a gateway. You set up a PC with 2 network interfaces cards, NICs, I call them NICs, which has one on each network, and that has the software to take the packet from one to the other. That's the gateway. Right? Until you set that up, there's no other device. So the default gateway, you ping that router 1. Once you ping that router 1 and you get a response, that's step 1, then you know, hey, you know what? That works. Let's see if I could ping the next interface on the next hop, which is step 2. Right? And for those who did the WAN course, when you did, you would have seen that that's how you would have done a diagnosis, right? You could ping the first router, then you pick the next one, and then you keep going on. Step 3. If you're getting through with router 2, then you're seeing if I could ping from the web server. Now, in most cases, the thing about it is that you may get a return packet coming in from each of them. And let's say you ping from your ping router 2 and it works, but when you start to ping the gateway, the packet doesn't return. And that is where the problem is. So then you see, if you're an admin on the one end and you do not have management of any of these interfaces, that's where the problem, or the devices, sorry, that's where the problem is. Because it's like you pinging google.com. Google.com is down, but everything else in between works. You can't fix google.com. You don't have access to that system. Right? So that's the problem. But in here, when you're in a network environment where you are administrator and engineer, you have access to this. Or you could speak with people who have access and tell them, hey, I cannot ping your web server because of this. They might tell you, okay, well, no, it's supposed to be working. And then normally you use another PC somewhere else and try it. Or you ask them, I'll show you. You ask them, give me evidence that is working for you. And normally they will do a ping and show that is working, a live ping that is working for them. So that's a good way to check. Other than that, you go on the web server and see if it returns. Now, what's happening is that as it goes and you have a return, and normally they're supposed, all the returns is showing you that there's packets are coming back and the routers are bringing back the packets. Now, normally once you do a ping at step 1, you're getting a step 6 is automatically checked off because you're getting a packet coming back. It means the router 1 knows how to send it back to you. When you do a ping at step 2, and you get 5, is you're getting a response, you automatically got 5 working, coming back. So when at step 3, when you do the ping at step 3, and you're not getting a response, well, your problem could be between here and here. And you're not so sure, and that's where you have to drill down. As an admin, you may access the router, R2, or switch 3, and then you work from there, and see where the problem is. The cool thing, all the routers, most routers will be able to do ping, ICMP ping on equipment. So you could, from a router 2, you actually could initiate a ping to this equipment and see if you get a response. Right, skip that. Right, so it's forward and back at step 6. Right, so this list analyzing the layer 3 part 3 network hop by hop in both directions, which I just described. It shows which hop in the layer part, and you can look further at those details. Like I said, you check further and further as you go along. Right? I'm really sorry about that. I hope you guys are checking the PDF and following with the PDF, right? Right? If the layer 3 problem discovers step 1 tree or fails, might be related to Ethernet or other layer 2 issues. 1, 2, 3, 4, 6. Why didn't do 5? Who's 5? 5 is coming back. Right, so this can be related to Ethernet or other layer 2 issues, right? Because they're talking about switch related stuff. So that's why they put those steps if it's those failed. Right. So if it's also determined PC1 cannot even send a packet, means that that is to the default gateway, meaning step 1 fails. Well, you know what's happening there. You can't send it to you cannot ping your gateway. Something is wrong. Your gateway may be not configured. The gateway, you maybe have a misconfigured IP for your gateway. Or you have a problem that could be more layer 2 problem, which is more switching, VLAN stuff, or wrong VLAN. The switch port is already disabled. Switch port is shutdown mode. Those are the main things that could happen, right? You have look at MAC addresses, switches used, interface, the VLANs that should be used. You check those things. Most cases, and especially with the GNS tree, all these guys should be okay. This one is MAC address stuff should be okay. Switches, I have not configured the switches to do failure of MAC address switching and MAC address forwarding. So that part, that layer 2 stuff is going to be good. This could actually be a questionable stuff. The interfaces used is also something that you should look at as your troubleshooting. Not so much, this should be fine. MAC address of PC1 and Aaron's LAN interface. MAC addresses are globally unique, so you don't have to worry about that. The only problem you might have to worry about is if they are actually duplicates. Right? If they're duplicates, which is not supposed to happen, it can happen. VLANs and VM virtual machines, and you can actually spoof MAC addresses and stuff. It can happen. If they have duplicates, then it might have a same MAC address being broadcast on that switch, and the switch is trying to figure out, well, which port is the correct MAC address, and that's where you're going to have MAC address flapping back and forth. It'll say, okay, port 1 has it, port 2 has it, and it'll be back and forth. So for example like that, you might see a ping returning to you, and then the next ping, you're not seeing the ping. It'll get a timeout, and it'll get a return and a times out. So it's going to be return, timeout, return, timeout. So that's a possibility of what could happen if you have duplicate MAC addresses. But 2 devices have that. Right, so these 2 are more or less good. So you don't have to worry about these 2. It's all in between is where your troubleshooting is. Sorry, that's this side, yeah? All your troubleshooting in here. Right, just wrapping up this piece. We have 10 minutes. Right, what tools would you use to diagnose a problem of layer 3? Well, this is choose 2. Sorry? At layer 3, sorry. Oh, layer, oops. You guys didn't see layer 3. Right, looking at ANC. Right, so using traceroute and thing, yes. Right, ARP is more between ARP is more layer 2. All right, trace path doesn't exist, not a correct command. And if you do MAC address, show MAC address table, EDD, right? This is basically ARP is a layer 2 to layer 3 mapping as a L3, but it shows that layer 2 is working. Show MAC address table is basically on layer 2 to layer 1 mapping, right? But that also shows that layer 2 is working. Right, so there's the two commands, ARP and show MAC address table are two ones. One is layer 3 to 2 and one is layer 2 to 1. Some commands you use for your configuration. I was supposed to give you some show commands, so you could always just put out into your equipment. So I'll do that, so when you use the assignment, you could actually just copy paste the commands straight into your, I can't remember if I gave you it. I think it's somewhere. I'll check it over. Where you just copy paste it and then you execute. Right. So that's based on that chapter. Let me go to the next one. You know what? Let me jump straight into spanning tree stuff. Yeah, you have more Ethernet plan stuff. So let me see if I can go straight into span tree, and then I'll let you guys read the rest of the slides. This is a long one. I think hopefully I'll be able to cover this on Tuesday. What is this thing doing? Show, man. Right. Kind of long, yes. Oops, go back. Yep, a lot of chapters in this, a lot of different versions of the books, right? So it's chapter 2 of this one, 2016 version, chapter 9 of the 2019 version, and then chapter 10 as well of the 2019. These two actually kind of span in tree and at a channel. They kind of split this, they split it up into two chapters in the newer versions. In the 2024/2025 version, which we're not covering right now because that is new revision of the course, it'll be the same 9 and 10. This more or less, yeah. My slides are literally free on this, on the chapters. I may have modified some of the content of the text and the diagrams, but they more or less came out from the chapters. This slide is kind of based on the 2016 version. So all my slides are based on 2016, but I checked over on the 2019 to see what content has changed or updated. Right, yeah, I recommend using 2016. You could use it 2019, that's why I put it there. So in case that those who have 2019, you could check that out. I mean, you could get it online. I think you already know how to do that. So Amazon or wherever else. Yeah, yep. Yeah, well, you have other sites too other than the 7 Cs. All right, so so we're looking at spanning tree, root bridge selection, you have port fast, BPD you got, and then this is the last piece with ether channels. So that's much later. Yeah, that's the other set of slides. All right, yeah, that's these later. Right, so in a home network, to save on it, use multiple switches, different locations. Issue of one link being accidentally disconnected, especially when you have you uplink one guy. So imagine you have about 5 PCs connected somewhere, and then that uplinking to another switch then goes to the internet, and somebody trips on that cable, and then that's it, you lose connection, right? So what you do, you may run on a next cable. Now in a home network, those are not managed switches that actually deal with loops. So loops are going to happen. You take a switch and you put in 2 cables. There's a high chance it might be able to stop it, but there are other cases where you're going to have a loop happening and then broadcast storm is going to go. So you don't really do that. But in a network with more managed switches where they have something called span tree protocol, they ensure that no loops are formed. Of course, what we do is the next step is to create aggregated links for redundancy, multiple link failures. You get like a higher bandwidth. Well, in these days, these networks 2 gigabits because it's 2 gigabit links. So you get, not only do you get redundancy. So if somebody pull a cable, right, and the idea is that you run the cable in 2 different locations. Ideally, fiber is the best way, because how this works is that you make sure that the cables are kind of close to the same link as possible, because there is going to be a delay between the 2 cables. The longer one gets, there's a slight delay in the transmission of frames. So if you go longer, you're going to have a problem where one port is going to get the frame earlier versus the other port, which gets the frame later. It has to buffer it. TCP is going to pick up something delayed, and it might drop.
The considerations for the connection between the device and the router, or between the router and the...
No, that's between switch and switch.
Okay.
Right? Let me just do it. I don't know why I don't have a diagram. So you have a switch here, next switch here, and let's say S1, S2. And let's say you run this cable straight on the floor and you're good to go. On this other one, you run all over the walls and things just to make it look nice and neat. And you have it here. So this is maybe 10 meters. And this guy is over 50 meters. The frame is going to take less time to come across here. Milliseconds, right? Really short, but it does make a difference sometimes. Versus a frame coming across here. Right? So you have milliseconds, ms, as your delays. 1 or 2, it might be 1 or 2 milliseconds. I'm not so sure. You have to test it out. It might be less. But is that delay could end up having trouble, because the buffer here, especially with a lot of traffic coming in. Remember, you're looking at giga traffic. You're going to have like a lot of data coming in. It's going to fill the buffer up, and the frame receive late might be all the way on the top or bottom of the stack. And then your TCP is going to see, well, I'm not seeing the rest of this other frame, because what happens is that it's going to take the data and say, okay, you have 5 frames coming across for this data, like a web page. Out of that 5, 3 is going to go through one link, 2 is going to go through the other link. And we're going to interleave. So we're going to do 1, 2, 1, 2, going on that link, going across. On the other side, that switch has to take that and send it to forward it to the respective device. That device might actually get the delayed. I'm getting 1, I'm getting 3, and then 2 and 5 is later. I'm getting 1 and 3 first, or 1, 3, and 5 first, and then 2 and 4 I'm getting later. So TCP now is seeing the PC has to take this and buffer it, and then TCP has to say, okay, well, I got the other frames, good, I'm good. If it delayed, so you have to be careful that you cannot keep it minimum distance. You could experiment. You guys could do that. You could take one switch. See, all this is nice to do things to test out, right? So what I do is I could actually go out and do that in lab. Put one short cable, and then we literally take a box, crimp the 2 ends of the box, so we're getting like, okay, let's go up to like 100, almost like 100 meters, 50 meters, crimp the 2 ends, plug it in the switch, and then see how the channel performs over that. That's actually a nice experiment. And see how it performs. And we'll pass like gig traffic through the link and see what. So that's something to do, nice to test. Right, I did not go into more detail. I will stop in about now because we're done. All right, so I'll stop here. And I will resume this spanning tree on Thursday. I might be going through this really fast because it's like 60 slides to go through. So you guys can read ahead if you want. Again, all this is based on, it's literally almost like text, almost copy paste. So some blocks of text, and that's making this up. So it's not like, yeah, some things I'll add in, other things I'll remove because I'll condense in what the text has. And the text already condensed. So it's really heavy. All right, guys, I think that's it. I will see you on Tuesday. All right. Any questions for the assignment, email or forum. I'll post up whatever I said I'll put up for the assignment to help you out. I'll put that up. Questions related to the labs?
So you have to reconfigure server 21. I think that was the shadow notifier.
Yeah,
So you basically reconfigure it to
lab 2.
a device.
Lab 2?
Yeah. That was what I did before.
Alright, let me see if I could open this up. Alright, so I'm just gonna end off the Zoom and the stream, and that's it, right? So this will just be a side demo if you guys want to see. So it's all for those who are in person. Alright, thanks. Anybody else for attendance? Think we're good? Alright, so I'm just gonna end the Zoom now. And my stream.